እንዴት ናችሁ የተከበራችሁ የዩቲዩብ ቻናል ቤተሰቦች? ይህ የኢትዮ ዩኒቨርሲቲ ኤግዛም ሶሉሽን ሀብ ዩቲዩብ ቻናል ነው። በዚህ ዩቲዩብ ቻናል የተለያዩ የማውጫ ጥያቄዎችን ስፔሻሊ ለሜካኒካል ምህንድስና ተማሪዎች የሚሆን ማውጫ ፈተና ጥያቄዎችን እየሰራው ማቅረብ ይታወቃል። በዚህም ቪዲዮ ባለፈው ክፍል የቀጠለው የ2015 ኤግዛም ኦር ማውጫ ፈተና ቁጥር 2 ኦር ፓርት 2 ይዤላችሁ መጥቻለሁ። ጥያቄዎቹ ላይ አብዛኛው ጥያቄ ችግር እንዳለበት እና የጥያቄው ድግግሞሽም እንዳለ አይቼበታለሁ። ስለዚህ የተደጋገሙ ጥያቄዎችን እያወጣው ኖርማል ችግር ያለበትን ጥያቄውን ኤዲት እያደረኩ ነው የሚሰራላችሁ። ቪዲዮ ሲጀምሩ ላይክ አድርጋችሁ እንድትጀምሩና በቪዲዮቹ ላይ ኮሜንት እንድትጽፉ፣ ለቻናላችን አዲስ ከሆናችሁ ቻናሉን ሰብስክራይብ እንድታደርጉ ብላለኝ። ቀጥታ ወደ ጥያቄዎች እገባለሁ። በክፍል 1 ወደ 22 ጥያቄዎችን ሰርቻለሁኝ። አሁን ወደ ከ23ኛ ጥያቄ ቀጥሎ ያለውን እየሰራን እንሄዳለን። ጥያቄ ቁጥር 23 why hardening process of a heat treatment for a component recommended? why hardening process of a heat treatment for a component recommended? A, to charge the inherent strength of the material so as to resist high external load. B, to enhance the surface roughness of the material that has been failed to be attained by machining. C, to enhance the surface hardness of the material to withstand an impact load. And D, to improve the stiffness of the material for betterment of resisting deflection. So from these reasons, why this heat treatment for a component be recommended? Or from this, the given alternative, for which one this heat treatment of a component recommended? So let's see the explanation. So here in A we have to change the inherent strength of the material so as to resist high external load. So in this case, this option is not accurate or not correct regarding this necessity of hardness or hardening the material, because the primary purpose of hardening is to increase the surface hardness of the material rather than changing its inherent strength. So here, when we say this hardening, it is primarily objective is to increase the surface hardness of the material rather than changing its inherent strength. And hardening typically involves heating the material to a certain temperature and then rapidly cooling it to achieve a hardened structure. So from this reason or from this point of view, the choice A is not correct or not accurate. When we come to B, to enhance the surface roughness of the material that has been failed to be attained by machining. So this, from this point of view also, this hardening is not a process used to enhance surface roughness. It is not a process used to enhance surface roughness. This surface roughness is typically addressed through machining process, not through heat treatment. So hardening is focused on modifying the material's microstructure to improve properties like hardness and wear resistance. So from this point, or due to this reason, this choice B is also not correct. So this the primary objective of this hardness is not to enhance surface roughness. C, to enhance the surface hardness of the material to withstand an impact load. So this hardening process in heat treatment is recommended to increase the surface hardness of a material, making it more resistant to wear, abrasion, and impact loads. And hardening is commonly used to improve the durability and performance of components subject to mechanical stress and forces. And this is, from this point of view, to enhance the surface hardness of the material to withstand an impact load. This is right or correct answer, in which this hardening treatment is recommended. In D, to improve the stiffness of a material for betterment of resistance to deflection. The hardening is not primarily aimed to improve the stiffness of the material. So due to this statement is also false or incorrect. So stiffness more related to the material's elastic modulus, and hardening doesn't necessarily alter this property significantly. And if improved stiffness is the goal, other processes like alloying or heat treatment for specific properties may be considered. But in this case, this hardening or hardening treatment is not recommended. So in summary, option C, that means this one is correct because hardening is commonly used to enhance the surface hardness of a material, making better able to withstand impact loads. And other options do not accurately describe the main property of hardening process in heat treatment. So the hardening process of heat treatment for a component recommended for or to enhance the surface hardness of the material to withstand impact loads. So this is the correct answer. Next, question number 24. The coefficient of performance of refrigerator is the ratio of A, heat input to the evaporator to the heat output from the condenser, B, refrigeration effect to the work input into the compressor, C, heat output from the condenser to the work input to the compressor, D, refrigeration effect to the heat output from the condenser. So from this one, which one best describes this coefficient of performance of refrigerator? A, heat input to the evaporator to the heat output from the condenser. This ratio doesn't represent the coefficient of performance. This ratio doesn't represent the coefficient of performance or COP of refrigerator. So this the coefficient of performance is specifically in terms of the refrigeration effect and the work input into the compressor, not in terms of heat input and output. So from this perspective, this is incorrect. This is incorrect. The next, B, refrigeration effect to the work input into the compressor. The coefficient of, or this is correct, which shows the coefficient of performance for the refrigeration. So the coefficient of performance or COP for the refrigerator is defined as the ratio of the refrigeration effect or heat removed from the refrigeration space to the work input into the compressor. So this is expressed mathematically as the COP, which is refrigeration effect to work input. This COP is calculated by using mathematical equation, that's refrigeration effect over work input. So this is the correct answer. The next, heat output from the condenser to the work input to the compressor. This ratio also doesn't show or doesn't represent this COP or coefficient of performance for refrigeration. The other is refrigeration effect to the heat output from the condenser. This is also the COP or coefficient of performance is the inverse of this part. The inverse of this part. This is the inverse of the correct ratio. So this COP or coefficient of performance is defined as the refrigeration effect divided by the work input, not the refrigeration effect divided by heat output from the condenser. So in summary, the accurate representation of this coefficient of performance for a refrigerator is given by the formula, which is expressed in choice B, which compares the refrigeration effect to the work input into the compressor. So this is the correct answer for this question is B. This COP or coefficient of performance of refrigerator is it is defined as the ratio of refrigeration effect to the work input into the compressor. And mathematically, it is calculated by using the formula refrigeration effect divided by work input. So B is correct answer. So from this, the correct answer is B. The coefficient of performance of refrigerator is the ratio of refrigeration effect to the work input into the compressor. This is the correct answer. The others are not correct regarding this is the ratio of this is the coefficient of performance of the refrigerator. Number 25. Which one of the following statements describes the concept of engineering material? Which one of The following statement describe the concept of engineering material. A. Engineering materials are materials whose inherent behavior are identified and recognized by advantage of engineering design and development work. B. Engineering materials are novel materials identified by the material scientist. C. All engineering materials are available in market for construction and or fabrication of engineering products. Engineering materials are limited material obtained from different natural resources. So from this described concepts, which one best describes engineering material? So we can find the answer from the concept of engineering material. From engineering material, we have learned two parts for this course, which is engineering material 1 and engineering material 2. Here, when we see the first one, in A, engineering materials are materials whose inherent behavior are identified and recognized for the advantage of engineering design and development work. This statement is accurately describes or correctly describes the concept of engineering material. So these engineering materials are selected based on their properties, characteristics, and behavior that make them suitable for specific engineering applications. And the understanding of the inherent behavior of the material is crucial for making informed decision and engineering design and development. So this is the correct regarding this engineering material. The other is engineering materials are novel material identified by the material scientists. This statement is not correct. It is not correct. While material scientists may be identified and study new material, the concept of engineering is not limited to novel materials. So from this point of view, this choice B is incorrect. The other is all engineering materials are available in the market for construction and fabrication of engineering products. This statement is also not accurate or not correct. While many engineering materials are commercially available, not all engineering materials are necessarily found in the market. So we cannot find all engineering materials on the market. And from this point, this is incorrect also regarding engineering material. The other is engineering materials are limited materials obtained from different natural resources. This statement is also not accurate or not correct, since these engineering materials are not necessarily limited and they are obtained from various sources, including natural resources and the synthesized materials. And the availability of engineering materials is diverse, and they can be derived from natural resources, refined through manufacturing process, or created through advanced technologies. So due to this is also not correct regarding this engineering material. Therefore, in summary, option A correctly describes the concept of engineering materials by emphasizing their inherent behavior that are recognized and utilized for engineering design and development. And the other options either restrict the scope or misrepresent the characteristics of this engineering material. So due to this, option A is correct. Option A is correct answer regarding the engineering materials. So this is the correct statement. In which type of air conditioning system is the condenser located outside, remote from the evaporator, and uses interconnecting refrigerant lines? A. In packed air conditioning. B. In absorption-based system. C. In evaporative cooling. D. In spirit system air conditioning. From this one, on which type the condenser located outside, remote from the evaporator, and uses interconnecting refrigerant lines. So let's see the description or explanation. A. Packed air conditioning. In packed air conditioning system, both the evaporator and condenser are contained in a single unit, typically located outdoors, and this unit is often installed on the roof or on the concrete pad near the building. And the entire system, including the compressor, condenser, evaporator, is packed together, making it a self-contained unit. B. In absorption-based system. In this system, the condenser and evaporator are not typically located separately. In absorption-based air conditioning system, the condenser and evaporator are not typically located separately with interconnecting refrigerant line. Absorption chillers use a different principle relying on the absorption of refrigerant by a liquid observer, and the key component is absorption system are the generator, observer, pump, and heat exchangers. So from this is not the right answer. This is not the right answer. The other, in evaporator cooling. In evaporative cooling, evaporative cooling system operates by using the evaporation of water to cool the air, and this system do not have separate condenser. It do not have separate condenser. And evaporator units connected by refrigerant lines. Therefore, instead they typically use a fan to draw warm air through water. So from this point of view, this is also not correct. And D, in split system air conditioning, in this system the condenser is located outside, remote from the evaporator, and the two lines are connected by refrigerant. In a split system air conditioning setup, the condenser is located outside, remote from the evaporator, and the two lines are connected by refrigerant line. And this configuration allows for flexibility in installation with the indoor evaporator unit placed inside the conditioning space and the outdoor condenser unit located outside. Therefore, in summary, the correct option for the type of air conditioning system where the condenser is located outside, remote from the evaporator, and uses interconnecting refrigerant lines is D, in split system air conditioning system. Therefore, this split system air conditioning system uses the condenser located outside, remote from the evaporator, and uses interconnecting refrigerant lines. So this is the correct answer. The other, which one of the following is not the cause for tool wear? A, sliding of the chip along the rake face. B, low temperature along the rake face. C, sliding of the tool along the newly outward piece surface. D, high localized stress at the tip of the tool. There are so many causes for tool wear. And in A, it says sliding of the chip along the rake face. This is a common cause for tool wear. As the chip slides along the rake face of the cutting tool, it can lead to the abrasive wear, which is one of the mechanisms responsible for the deterioration of the tool edge. And in B, low temperature along the rake face. This is not typically the reason or the cause for tool wear. In machining, cutting generates heat at the tool chip interface, and low temperature along the rake for the face are not typically the cause for tool wear. And in machining process, tool wear is commonly influenced by factors such as friction, temperature, abrasion, and other mechanical forces. And high temperature rather than low temperature are often associated with tool wear due to the heat generated during cutting processes. So due to this is not the cause for tool wear. This one is the cause. And see, sliding of the tool along the newly cut workpiece surface. This is also cause for tool wear. This is also the main cause for tool wear, and the tool may experience abrasion and friction as it slides along the newly cut workpiece surface and leading to wear on the tool edge also. So this is the reason or the cause. The other, high localized stress at the tip of the tool. This high localized stress at the tip of the tool can result in tool wear. This can be cause for this tool wear, particularly in the form of mechanical wear or chipping. And excessive stress concentration can lead to the deformation and failure of the tool material also. So this is also another reason or cause for tool wear. So in summary, when I summarize this, option B is not a common cause of, or the concept which is expressed in option B is not a common cause of tool wear, as low temperature along the rake face are not typically associated with wear issues in machining process. And the other options involve mechanisms that contribute the tool wear during cutting operations. So from this B is not the common, or the idea which is expressed in B is not common cause for tool wear. So the correct answer is this. From the listed one, this low temperature along the rake face is not the cause for tool wear. Next, which one of the following is known as corrective maintenance? Which one of the following is known as corrective maintenance? So this is the concept of maintenance engineering, and we have different forms of maintenance. So which one of these are? known as corrective maintenance. A. Predictive maintenance. B. Scheduled maintenance. C. Breakdown maintenance. D. Preventive maintenance. So from the listed one, which one is also called corrective maintenance? Okay, let's see the explanation. Here we have predictive. When you say predictive maintenance, it is a proactive maintenance strategy that involves monitoring the condition of equipment to predict when maintenance is needed. So this is the proactive maintenance type. It is also called proactive maintenance. And this is often done using various monitoring techniques such as vibration analysis, thermography, or oil analysis. And by predicting when equipment is likely to fail, maintenance activity can be scheduled just in time to address potential issues, minimizing unplanned downtimes. So this is not the correct answer. This is not the corrective maintenance. It is proactive maintenance. The other is scheduled maintenance. This scheduled maintenance, also known as time-based or calendar-based maintenance. It is time-based or calendar-based maintenance, which involves performing maintenance activities at predetermined intervals, regardless of the actual condition of equipment. And this could include routine inspection, lubrication or part replacement on the schedule. And while it can help prevent breakdowns, this scheduled maintenance can prevent breakdowns. It may lead to unnecessary maintenance if performed too frequently. So this is what is scheduled maintenance. It is not corrective maintenance. The other is breakdown maintenance, which is usually what we call it corrective maintenance. So when you say breakdown maintenance, it is corrective maintenance. When we say corrective maintenance, it is the type of maintenance which is performed after happening of some breakdown or some failure on the machine parts. And in the preventive maintenance, this preventive maintenance is proactive approach that involve performing maintenance activities at predetermined interval to prevent equipment failure also. This is also proactive maintenance. So the others are all proactive maintenance type. This one is also proactive, this is proactive, and this one is also proactive. So this is the corrective maintenance type. Therefore, while each type of maintenance has its advantage and disadvantage, option C, which is breakdown maintenance, is specifically known as corrective maintenance, as it involves correcting issues after equipment failure has occurred. This choice is correct answer. This breakdown maintenance is known as corrective maintenance. The other, during which type of project did the project manager focus on developing the project infrastructure needed to execute the project and developing clarity around the project charter and scope? A. During execution, B. During evaluation, C. During startup, and D. During completion. So when I explain each options, during execution, this execution is focused on carrying out the project plan. It is focused on carrying out the project plan and involves tasks such as coordinating the people and resources. It's also managing the stakeholders' expectations and monitoring and controlling the project. So the focus during execution is on delivering the project objectives as defined in the project plan, rather than providing the infrastructures which are needed for project execution. In B, this is not correct answer. In B, during evaluation, this evaluation stage typically comes after the completion of the project. Usually, we evaluate the project after completing the project. It may be during the project also. So within the project, or when we are performing the project, we can evaluate the project to ensure whether we are in line with our plan, ahead of our plan, or that of lagging from our plan. So it involves assessing the project's performance, outcome, and lesson learned during the stage, or during this stage. The project manager and the project team analyze what went well and what could be improved for the future projects. So this is also not the right stage to focus on providing this infrastructure which are needed for the project. The other is during startup. This startup stage is where the project is initiated and the foundation elements are put into place. So this includes developing project infrastructures needed for execution, and establishing the project team, defining the project charter, and clarifying the project scope also. So in this stage, or in this is the correct stage that the project manager should develop the project infrastructure to provide project infrastructure needed for execution, establishing the project team, defining the project charter, and clarifying the project scope for the stakeholders. And it sets the direction for the entire project. This is during a startup, we have to perform these all activities, because this the activities or every activities which are going to be performed on entire project must have to be in plan. And when we set these concepts on plan during starting up of the project, that is what we have to follow, or the project manager to follow this direction which is set as the plan. So this is the correct answer. The other is during completion. The completion stage is the final phase where the project is closed out and any remaining activities or documentation are finalized in this stage. So this includes handing over deliverables to the stakeholders, conducting a project review, and ensuring that all the project closure activities are completed. So in summary, the correct answer for this is C. C is the correct answer. That's, during the startup, so we have to set, or the project manager must have to set all infrastructures which are needed for the execution of the project, and to set the scope of the project also at the startup phase of the project. For this stage where the project manager focus on developing the necessary infrastructure and establishing clarity around the project charter and the scope, setting the stage for successful project execution. So after this stage, during the startup, the project manager focus on developing the project infrastructure needed to execute the project and developing clarity around the project charter and scope. So this is the correct answer. Next, which of the following statements incorrectly discuss about measurement system? So from the given list, which one is incorrectly discussed about the measurement system? A. Mechanical measurement system use mechanical element and system to quantify variables. B. Mechanical measurement system are used to measure small frequency variable regardless of any data acquisitions. C. Electromechanical measurement system are used to record measure quantity easily compared with mechanical system. D. Electromechanical measurement system use a combined mechanical and electrical element to process signals. When we go to this at choice A, the mechanical measurement system use mechanical element and its system to quantify variables. This statement is correct. This mechanical measurement system utilizes mechanical components and mechanism to quantify physical variables such as length, force, pressure, and displacement also. And in B, mechanical measurement system are used to measure small frequency variables regardless of any data acquisitions. This statement is incorrect. This mechanical measurement system are not typically used for measuring frequency variables. This frequency variable is often associated with electronic or electromechanical systems such as frequency counter or oscilloscopes, and these mechanical systems are more suitable for measuring mechanical properties. So due to this one is incorrect. The first one is correct. This is incorrect. The other, electromechanical measurement system are used to record measured quantity easily compared with mechanical system. This statement is also correct. This is correct statement. This electromechanical measurement system combine mechanical and electrical elements to process signal and often used for recording and displaying measured quantities. So they can provide advantages such as automation, either data acquisition and integration with the electronic system. So this is the correct one regarding this measurement system. The other is electromechanical measurement system are a combined mechanical and electrical element to process a signal. This is also the correct one. So this statement is correct. when we say this electromechanical measurement system, they incorporate both mechanical and electrical components to process signals. So this often include sensor to convert physical quantities into electrical signals, which are then processed electronically for recording, display, or control purposes. So this is also correct statement regarding this measurement. Therefore, this the concept is under choice A. C and D provide accurate description of mechanical and electromechanical measurement systems, while at choice B it is considered as incorrect because it misrepresents the typical application of mechanical system in measuring frequency variables. Therefore, this part is incorrect regarding measurement system. The other are correct. This A is correct, C is also correct, and this is correct also. Next, draft tubes are used for reaction turbines but not for impulse turbines because draft tubes are used for reaction turbines but not for impulse turbines because A. Impulse turbines such as Pelton are open to the atmosphere and kinetic energy of the fluid leaving the runner is very small fraction of the total available read. C. Considerable portion of the kinetic energy is available as the exit of the runner of the reaction turbine. C. Since reaction turbines they operate under small heads, the exit kinetic energy constitutes a significant portion of the total head. D. All. So from the listed choice, which one is reason for using this draft tube at reaction turbines but not for impulse turbines? So here I have provided the explanation. In A, it says impulse turbines such as Pelton are open to the atmosphere and kinetic energy of the fluid leaving the runner is very small fraction of the total available head. So yes, this is the reason why these draft tubes are not applicable in impulse turbines. So the statement, impulse turbines such as Pelton are open to the atmosphere and kinetic energy of the fluid leaving the runner is very small fraction of the total available head is one of the reason why draft tubes are not typically used in impulse turbines. So due to this, the characteristics of this impulse turbine with their high exit velocity and efficient kinetic energy extraction make this draft tubes less necessary for this type of turbine, that is this impulse turbine. So this is the statement which is expressed in choice A is the reason that we haven't used or we are unable to use this draft tubes in case of this impulse turbines like Pelton turbine. And B, considerable portion of kinetic energy is available as the exit of the runner of the reaction turbine. This statement is generally correct. In reaction turbine, a portion of the kinetic energy is available as the exit of the runner. And the important point is that in reaction turbines, kinetic energy recovery is significant, especially compared to that of the impulse turbine. And the draft tube in reaction turbines help to convert this kinetic energy back into potential energy. And that's the general idea that kinetic energy is present as the exit of the runner is in a reaction turbine is accurate, and that the draft tubes are used to recover this energy. So for the case of this, the reaction turbine, this is why we prefer this draft tubes. C, since reaction turbines operate under small head, the exit kinetic energy constitutes a significant portion of the total head. So in reaction turbine, which operate under a small head, the exit kinetic energy constitutes a significant portion of the total head, and these draft tubes are used to recover this kinetic energy and convert it back into potential energy to improve overall efficiency of the turbine. So in impulse turbines like Pelton, the kinetic energy as the exit is already very small compared to that of the available head, and so as this draft tubes are not necessary. Therefore, from this all expressions are that the reason that we prefer this draft tubes for reaction turbines and the reason that we not use draft tubes for impulse turbines. So this D is the correct answer. These all statements are the reason that we use draft tubes for reaction turbines, and the reason that we not use this draft tubes for impulse turbine. Next, which one of the following activities is not vital in selection of material handling equipment for the specific product? A. Identifying the economically or the economic feasibility of the material handling, whether it is technically feasible, equipment type, and less costly. B. Satisfying the material flow requirement. C. Identifying the previous material handling equipment and administrative body decision. D. Identifies the selection parameter, criteria, and values to set the material flow requirements. So simply we can visualize these choices and we can answer the question simply, but it is better if we describe these choices. So let me describe the choice. Here, in case of A, identifying the economic feasibility of the material handling, whether it is technically feasible, equipment type, and less cost. So this is the correct, this is vital and correct one. So it is this activity is vital in the selection process. It involves evaluating economic feasibility of the material handling equipment, considering factors such as initial costs, operating cost, maintenance cost, and overall cost effectiveness. And it ensures, or this ensures that the chosen equipment is not only technically suitable but also economically viable or feasible. So this is the correct one. And B, satisfying the material flow requirement. This is also crucial. This is also crucial activity in the selection process. So the material handling equipment selected should be capable of satisfying the material flow requirement of the specific product. So this is another activity that we have to perform during material handling equipment selection. The other is identifying the previous material handling equipment and administrative body decision. This is not considered as vital or crucial or important in selection process of this material handling equipment. So no need of this identifying the previous material handling equipment and administrative body decisions to select right material handling equipment or machine for specific use. The other, identifying the selection parameter, criteria, and values to set the materials flow requirement. This is also a vital or important thing that we have to perform during this material handling equipment selection process. So it involves identifying the selection criteria and values that will be used to evaluate and choose the most suitable material handling equipment. And this criteria may include factors such as capacity, flexibility, safety, and adaptability to a specific process. So this is also the vital activity. This is also the vital activity, but this is not the important activity or crucial activity. So from this, the ideas on choice A, B, and D are vital activities in the material handling equipment selection process to ensure economic feasibility, satisfying material flow requirement, and establishing criteria for evaluation. And at option C, it's not considered as vital or important as relying solely on the past decision may not address the current and the specific requirement of the operation. So which one of the following activities is not vital? This the idea at A is it is vital and crucial. This is also vital and crucial, and this is also vital or crucial. But this is not vital. This is not vital. So the correct answer is choice A, C. The next, what's the advantage of considering a fatigue stress concentration factor than a static concentration factor or a static stress concentration factor? A, fatigue stress concentration factor will support to approximate the intensified stress of a machine element under variable load in its stress riser area. B, fatigue riser concentration factor consider the effect of poor surface roughness of a machine element. C, fatigue stress concentration factor will support to approximate the intensified stress of machine element under combined bending and shearing load in its stress riser area. D, fatigue stress concentration factor approximate the nominal stress riser condition. So from this one, which one is the advantage of considering fatigue stress concentration factor than static stress concentration factor? Here, the correct answer for this choice is the concept or the idea at choice C, fatigue stress concentration factor will support to approximate the intensified stress of a machine element under combined bending and shearing loads in its stress riser area. This is the reason why we select or we give high concentration on fatigue stress concentration factor. So the advantage of this considering the fatigue stress concentration factor over the static stress concentration factor is that the fatigue factor takes into account that the effect of variable loading conditions such as cyclic or fluctuating load, which are common in fatigue situations. And additionally, it considers the combined effect of bending and shearing load on the machine element, providing a more realistic representation of the stress concentration in the stress riser area during fatigue loading. And this fatigue stress concentration factor are particularly important for components subject to repetitive loading, where the material experiences fatigue over time. So this is the reason why we prefer this the emphasis, or we prefer this fatigue stress concentration factor. So this is one of the advantage of this one. So the advantage of this considering fatigue stress concentration factor than static stress concentration factor is that this fatigue stress concentration factor will support to approximate the intensified stress of a machine element under combined bending and shearing load in its stress riser area. So this is the correct answer. This is the reason, or this is the correct reason why we consider this fatigue stress concentration factor than that of the static stress concentration factor. Next, which one of the following is not categorized under the process of signal conditioning? A. Amplification, B. Attenuation, C. Filtering, D. Sensing. So from this one, which one is not categorized under the process of signal conditioning? Here, when we say this amplification, this involves increasing the strength or magnitude of signal, and this amplification is commonly used to boost the amplitude of the weak signal, making it stronger and more suitable for further processing or transmission. And when we say this attenuation, this is the opposite of that of amplification, and it involves reducing the strength or magnitude of the signal. And this process is often used to decrease the amplitude of the signal to an appropriate level to mitigate interference. And C, when we say filtering, this is the process of selecting or modifying a specific frequency component of a signal while attenuating others. And filters are used to remove unwanted noise or to extract specific information from the signal. And when we come to this D, sensing, this involves the detection or measurement of a physical quantity or stimulus such as temperature, pressure, light or sound. And the goal is to convert the physical parameter into electrical signal that can be further processed or analyzed. Therefore, while amplification, attenuation, and filtering are all part of that of the signal conditioning, this sensing is more related to the initial detection or measurement of physical parameter before any signal conditioning takes place. Therefore, from the given alternatives, this sensing is not that part. This sensing is not the part. This is the part of that of the signal conditioning, but sensing is not the part of signal conditioning. So from the listed one, the one which is not categorized under the process of signal conditioning is sensing. This sensing is the correct answer. Other, with the increase in cost of preventive maintenance, the breakdown maintenance cost will be A. Increase, B. Increase at a faster rate, C. Decrease, D. No change. So that means when we increase the cost of preventive maintenance, what about this breakdown maintenance? Here, this is the graphical representation of the maintenance costs. And here we have maintenance cost, and here we have frequency. Blue shows, this blue part shows the repair cost, and this yellow shows the preventive cost, and this black shows the total cost. So here we have preventive maintenance, predictive maintenance, and breakdown maintenance. So when we invest less amount of cost on preventive maintenance, the breakdown cost or the occurrence of the machine breakdown is high. So when high amount of breakdown is occurred,
or if the frequency of the maintenance work is high, the cost that we invest on breakdown maintenance or for maintaining that part is increasing. And if we invest high amount of cost on preventive maintenance, the probability of occurrence of the failure or the machine part breakdown is less and less. And due to this, the cost that we invest on breakdown maintenance is low or decreasing. Therefore, here we have invested the high amount of cost in preventive maintenance, and the amount of or the frequency of occurrence of failure of the machine part is less, and the cost we are investing on breakdown maintenance is less and less. Therefore, from this concept, this choice C is correct answer. When we increase the preventive cost or preventive maintenance cost, the breakdown maintenance cost will be decreasing. So this is the correct answer for the given question.
When increase in cost of preventive maintenance, the breakdown maintenance cost will be decreased. This is the correct answer. The other is a process in which sheet metal is pressed into a shaped die to form an open-ended cylindrical shape recognized as A. Drawing operation, B. Shearing operation, C. Bending operation, D. Spinning operation. So a process in which sheet metal is pressed into a shaped die to form an open-ended cylindrical shape recognized as A. Drawing operation, B. Shearing operation, C. Bending operation, D. Spinning operation. So let's see each type of operations. So when we say this drawing operation, this is a metal working process where a sheet metal blank is formed into a cup or shell shape by forcing into the die cavity with a punch. So this operation is typically used to create deep cup-like structure. And B, shearing operation. In shearing operation, it is a cutting process in which the sheet metal is cut along the straight line, and it involves the use of shearing force to remove material from the larger sheet metal, resulting in a straight line cut. And in C, bending operation, it is the process in which sheet metal is bent or folded along a straight axis, typically using a press brake or a similar tool. So this operation is used to create bend or angle or curved shape in the metal part. D, spinning operation. This spinning operation involves forming sheet metal into a cylindrical shape by pressing it against a rotating tool or mandrel, and this process is commonly used for creating open-ended cylindrical components such as tubes or containers. So therefore, in metal forming, spinning operation involves the process of forming sheet metal into a cylindrical shape by pressing it against rotating or mandrel, and this results in the creation of an open-ended cylindrical forms. So this spinning process is commonly used for producing items such as metal containers, tubes, and other cylindrical operations. So from the listed one, this spinning operation is the correct answer for the given question. So the process in which sheet metal is pressed into a shaped die to form an open-ended cylindrical shape recognized as this spinning operation. So D is correct answer. The other, for a thick cylinder whose stress condition using polar coordinate system are related with radial 90 megapascal, circumstantial 100 megapascal, and longitudinal 60 megapascal stresses, and determine the equivalent von Mises equation. So here we have given that radial stress, circumstantial, and longitudinal stress, and we are asked to calculate the von Mises stress. So A 25 megapascal, B 36 megapascal, C 76 megapascal, and D 50 megapascal. So here we have given that radial stress, which is 90 megapascal, circumstantial stress, which is 100 megapascal, and longitudinal stress, which is 60 megapascal. And to calculate the equivalent von Mises stress, we can use this formula. This is general formula to calculate equivalent von Mises equation or von Mises stress. And for a thick cylinder under pressure, the shear stress for thick cylinder, we have given the thick cylinder. So for the thick cylinder under pressure, the shear stress can be assumed to be negligible, so they can be ignored in the von Mises equation. So we can ignore this shear stress part because when we compare with during this thick cylinder under pressure, this shear stresses are considered as negligible. So from this concept, so we have radial stress, longitudinal stress, and circumstantial stress, and when we plug in the values within the equation, we found this value which is around 36 megapascal, 36.06 megapascal. Therefore, the equivalent von Mises stress for the given stress state is approximately 36.06 megapascal, and the correct answer with this value is choice B. Choice B is correct answer. So this part is the correct answer. The other, which one of the following statements is incorrect? Which one of the following statements is incorrect about the system element used in the mechatronics or measurement system? Which one of the following statements is incorrect about the system element used in the mechatronics or measurement system? A. Analog digital converter is used to change signal to be presented in digital form only. B. Difference amplifier is one of the op-amp family used to amplify the output of sensor signals. C. Transducers are control system element and can be used to signal from one form to another form to best fit the preceding signal process. D. Sensors are the primary element which support to quantify the physical measure variables. So from this, which one is incorrect about the system element used in mechatronics or measurement system? So let's see the explanation. Let's explain each terms. When we say this analog to digital converter is used to change the signal to be presented in digital form only, this statement is correct. This statement is correct, as this analog to digital converter is a device that converts analog signal which are continuous in nature into digital signal which are discrete. And B. Difference amplifier is one of the op-amp family used to amplify the output of the sensor signal. This statement is also correct. This difference amplifier, which is oftenly implemented using operational amplifier or op-amp, amplifies the difference between two input signals. And the context of sensor, or in the context of sensor, it can be used to amplify the output signal of a sensor, providing a means to increase the signal strength for further processing. And C. These transducers are control system element and can be used to signal from one form to another to best fit the preceding signal process. This statement is incorrect. So this statement is incorrect because transducers are not typically considered to control system elements. These transducers are devices to convert one form of energy or signal into another, and they are commonly used to convert physical quantities such as temperature, pressure, or displacement into electrical signals that can be further processed by the control system. And however, the primary role of these transducers is in the sensing or measuring aspect of the system rather than being directly part of the control loop. And these control system elements often include controllers, actuators, and feedback mechanisms, but transducers are more aligned with the sensing and measurement side of the system. So this is incorrect. So the first one is correct. This one is correct. The next one is also correct. This is also correct, but this is incorrect. And in D, sensors are the primary elements that support to quantify the physical procedure, the physical measure variables. This statement is also correct. This is also correct. So these sensors are a device that detect and measure physical properties or change in the environment and convert them into electrical signals. So by doing this, they play this crucial role by quantifying physical variables such as temperature, pressure, light, or displacement, providing input data for the control or measurement system. So this all listed things are correct about the measurement system in mechatronics, except this the idea which is expressed in this C. So this is incorrect. So from this, the incorrect statement about the system element used in mechatronics or measurement system is This C, transducers are controlled system element and can be used to signal from one form to another form to best fit the preceding signal process. This is incorrect regarding this the mechatronics or measurement system. Next, which of the following statements is not true about second law of thermodynamics? A. The second law of thermodynamics is used in determining the theoretical limit for the performance of commonly used engineering systems such as heat, engines, and a refrigerator. B. There can be a machine whose effect is only to transfer heat from low temperature medium to high temperature medium. C. The inadequacy of the first law to identify whether a process can take place is remedied by introducing the second law of thermodynamics. D. The second law of thermodynamics asserts that energy has quality as well as quantity. So from this one, which one is not true about second law of thermodynamics? So let me describe. In A, here the second law of thermodynamics is used in determining the theoretical limit for the performance of commonly used engineering systems such as heat engines and refrigerant. This statement is true regarding the second law of thermodynamics, since this second law of thermodynamics introduces the concept of entropy and it is employed to establish the maximum efficiencies that may any heat engine or refrigerator can achieve. And in B, this is correct. This is correct. The other in B, there can be a machine whose effect is only to transfer heat from a low temperature medium to high temperature medium. This is incorrect, which is wrong regarding this second law of thermodynamics. Since this, according to this Kelvin-Planck statement of the second law, it is impossible to build a machine, that means it can be a heat engine, that operates in a cycle and transfer heat from a lower temperature reservoir to a higher temperature reservoir without any other effect. So this concept is crucial in understanding the limitation of heat engine and the conversion of the heat into the work. So this is incorrect regarding the second law of thermodynamics. The next, the inadequacy of the first law to identify whether a process can take place is remedied by introducing the second law of thermodynamics. This is also correct statement regarding second law of thermodynamics. Since this first law of thermodynamics, also known as the law of conservation of energy, states that energy is conserved in a system, and however it doesn't provide information about the direction of processes or whether they are feasible. So this second law introduces the concept of entropy and helps to determine the direction of spontaneous process and the condition for equilibrium. So this is correct. And D, the second law of thermodynamics asserts that energy has quality as well as quantity. So this is also true or correct regarding the second law of thermodynamics, since the second law of thermodynamics emphasizes that not all forms of energy are of equal value, and it introduces the concept of energy, which is a measure of quality of energy. As the energy undergoes transformation, its ability to do work decreases, and the reduction in the quality of the energy is described by its increase in entropy. So this is the concept, and due to this D is also the right one. So from the given alternative, the statement stated as B is not correct regarding second law of thermodynamics. So this B is incorrect statement regarding second law of thermodynamics. The next, one of the machine elements listed below will not support to transmit power from driving system to driven ones. Here, A, frictional element, B, sprocket, C, rivet, D, belts. When we say this friction element, these friction elements such as clutches and brakes are often used in this power transmission system to control the engagement and disengagement of power transfer. And B, when we say this sprocket, these sprockets are commonly used in chain and sprocket system for power transmission, especially in application involving rotating shafts. And in C, we have rivets, and when we say these rivets, they are mechanical fasteners used for joining two or more components together, typically by creating a permanent connection. While these rivets are essential for structural integrity and assembly, they are not designed to transmit power between the driving system and driving system. So here, when you say belt also, there may be different types of belt like V-belt and other timing belts. They are widely used for power transmission in various machineries and systems. So from this, the given alternatives, this rivet is not support to transmit power from driving system to driven one. The type of drag force which strongly depend on the form or shape of the body is A. Skin friction drag, B. Pressure drag, C. Viscous drag, D. None. So from this one, which type of this force or drag force to describe or depend on the form or shape of the body? So let me describe each type. When we say this skin friction drag is a typical or a type of drag force that results from the viscous shear force between the fluid and the surface of the object moving through it. And it depends on the smoothness or roughness of the surface. And this smoothness surface experience or its smooth surface experience lower skin friction drag, and while rough surface experience higher drag. And when we come to this pressure drag, it's also known as form drag, and this is a type of drag force that strongly depend on the shape or form of the body moving through fluid, such as air or water, and it caused by the pressure difference between the front and the rear of the object as the fluid flows around it. And when we come to this viscous drag is a broad term that include both skin friction drag and pressure drag, and it represents the overall drag force caused by the viscosity or thickness of the fluid as it interacts with the surface of the object. And D, none. In this choice, it suggests that there are no drag force depend on the form or shape of the body. However, in reality, these drag forces are influenced by the shape of the object. So the correct answer from the given part is pressure drag. This pressure drag, it is specifically referred to drag depend on the form of the form or shape of the body. Therefore, the correct answer for this is this pressure drag. It is also known as form drag, which is a type of drag force that smoothly depend on the shape or form of the body moving through the fluid. So the correct answer for this is this pressure drag. This pressure drag is the force, the type of drag force which strongly depend on the form or the shape of the body. Question number 42. If two pumps are connected in series, the performance curve should be or would be A. The sum of head of the two pumps as the same flow rate. B. The sum of the flow rate of the two pumps as the same head. C. The sum of head and flow rate of the two pumps. D. None. So here we have given that two pumps which are connected in series, and we are asked to now or to tell the performance curve which would be developed during this connecting two pumps in series. So here in A, the sum of the head of the two pumps has the same flow rate. When pumps are connected in series, the total head is the sum of the heads produced by each pump, and the flow rate remains the same for pump in series because they are part of the same hydraulic circuit, and each pump contributes to overcoming the total head against the system resistance. And in B, the sum of the flow rate of the two pumps has the same head. This means in series configuration, the flow rate remains the same for both pumps, and the head, on the other hand, adds up. So the correct statement is about the sum of head, not flow rate. So this is not correct answer. And in C, the sum of head and flow rate of the two pumps. So here, the sum of head and flow rate of the two pumps, this is not characteristics of the pump in series. In series configuration, the flow rate remains constant. And the head add up. So this option doesn't accurately describe the performance of the curve. So here in D we have none, and this is not correct because when pumps are connected in series, there are change in the performance curve, the head up, and the alteration in the pump system behavior is reflected in the combined performance curve for pumping in series. Therefore, in summary, the correct answer is A, because pump in series result in the sum of the head at the same flow rate. So when we connect two pumps in series, the result in the curve is the sum of the head at the same flow rate. So the correct answer is A. This is the correct answer. Therefore, if two pumps are connected in series, the performance curve will be the sum of the head of two pumps at the same flow rate. So this is the correct answer. This is the video that I have regarding this part 2 of this the exit exam of 2015 for mechanical engineering students. I have remaining questions around 62 questions, and I will divide this question into 2 parts, and I will come with the third part of this the exit exam for mechanical engineering students. And don't forget liking the video, subscribing the channel, as well as commenting on the video and sharing the video for your friends also. Thank you for watching the video until the end. Thank you.